everyone, welcome to a very short video about real functions. In the last video we've seen what it means to be a function. This is a special type of relation. Well, in this video, and we actually already gave an example at the end of the previous one, we will often look at functions from the real numbers to itself, so we can denote this as, for example, a function f going from R to R. Well, an element x is mapped to an element y, which is denoted by f of x. Often we really just write x is mapped to f of x. Well, just as a reminder, so this function here, it's really like a subset. So all tuples in the product R times R, for which there is a relation between the x and the y, namely that y equals f of x. So this is indeed a subset of R times R. And well, R times R, we've already seen this. We can represent this in like a coordinate system with an x-axis and a y-axis. So this is a plane, two products, so two directions, so two dimensions, and we can draw all these tuples for which these guys hold, and we'll give you some examples. Let's say a function f from R to R, where x is mapped to minus x, a function g, so you see this is really the name of the function. Often for functions we use small letters. Function g from R to R, where x is mapped to maybe just 1, and a function h from R to R, where x is, for example, mapped to the floor of x, and this is the smallest integer lesser or equal than x. So these are three functions, and the exercise is to draw the graphs of all these functions, because we know as a function, being a function from R to R, so this is really a subset of the plane R times R, so we can really draw it in the plane, and by drawing all those elements of the set, we actually get what we call the graph of the function. So let us try and do this. So the function f that maps x to minus x, this will be a straight line, and this will go like this. This is the function f. So this angle here is like 45 degrees. And for the first one, the function g maps, well, every element x is mapped to 1. So if you think about it, this is just this line which is parallel to the x-axis. So you see indeed every element is mapped to 1. And for the last one, well, what is the floor of x? So let us give some examples. Well, the floor of 1, for example, yeah, that's of course 1. The floor of 1.5, well, that's also 1. The floor of, let's say, what is the floor of minus 5? So minus 2.5, well, it's the smallest integer smaller, so this equals minus 3. So using this information, so if I denote all these 0 here, 1 here, 2 here, minus 1, minus 2, and so on, how does this graph looks like? So everything including 0, but not 1, is just mapped to 0. So this is this guy here, but 1 is actually mapped to 1. So 2 is mapped to 2, all the way up to 3, and so on and so on. So this goes like this. And then here what we see, every element, let's say minus 0.5, is actually mapped to minus 1. So this goes like this. And then if we're in between minus 2 and minus 1, then we're mapped to minus 2. And this also goes like this. Now, in the next video, we're going to look at how can we interpret formulas. Because math, you often think about formulas.